I'm going to change gears a little bit in this example, and we're going to go backwards from what we've done previously. And what I mean by that is now instead of having some sigma notation to evaluate, we need to write this series here in sigma notation. The very first things that you need to do is figure out the general term. So in my mind, I see this as 16 minus 1, the first term of 15. 24 is 25 minus 1, 35, 36 minus 1, and so on and so forth, all the way to 144 minus 1 for the last term. Well, 16 minus 1, that's 4 squared minus 1, 25 minus 1, 5 squared minus 1, 6 squared minus 1. We're going to go all the way to 12 squared minus 1. It looks like if we start at 4, and we'll go I is equal to 4, then we just need to take I squared and subtract 1. Beginning with 4, we're going to go all the way to 12. The little dot 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 here doesn't mean this goes to infinity because there's a term here, it just means there's a little bit missing right there. So again, our lower limit is 4. We're arbitrarily using I as a variable as long as it's the same. It doesn't matter. You could do n or x or y or whatever you'd like as long as it's the same. And then the 12 will go up here. We only need to write the index of summation on the bottom. We don't need to write that on the top. This is one possibility. If you wanted a different possibility, let's say that you wanted to start with your lower limit being 1, you could write this differently. We'll use n for this one. Instead of this first one being just n, which would be 1, we need to always add 3 to whatever n is to get that to get the number we want to square. So inside the parentheses, we want to do n plus 3 quantity squared, and then minus 1. And you can see this does work. For the first one, it'd be 1 plus 3, or 4 squared, minus 1, which is 15, and you can follow that through. We need to know where to stop. There's a couple different ways to figure out where to stop for this one. The first way is just to take n plus 3 and set it equal to 12, or you can set this whole thing equal to this last term of 143 and solve from there. So, if you did that, you'd have 143 is equal to n plus 3 quantity squared minus 1. We'd add 1 to each side. Then square root, you get n plus 3 is equal to 12, and then subtract 3 from each side, and n will be 9. So that ending value needs to be 9. That's the value that makes this general term equal to 143. Another way to do it, if you've already written this one, let's say you're just trying to rewrite your sigma notation with a starting value of 1, is to look at 4 and 12. From 4 to 12, there's going to be 4, 5, 6, 7, 8, 9, 10, 11, 12, or 9 terms. So it's not 12 minus 4, it's actually 9 terms. However, if we do take 12 minus 4, we get 8, and 1 plus 8 would also be 9. Just keep in mind that there's not 8 different terms for this one, there's actually 9. And same for this one if you had to write that out. So there's a variety of ways that if you know how to write the sigma notation with a different starting value and you want it to be 1, you can definitely figure that out. Either one of these is acceptable. Either one will be fine.